Hello viewers, tutorial 4, question 3, and we have a word problem to solve. So two positive whole numbers differ by 4. Their squares add to 296. Find the whole numbers. Well, maths is really a language. Instead of having sentences, it has equations. So when we solve a word problem, the first task is one of translation. We need to translate the English sentences into the mathematical equations. So this question is going to have one sentence corresponding to one equation. Two positive whole numbers, let's call those x and y. They differ, so difference would be the operation minus, so x minus y is 4. Their squares, so we're talking about the squares of x and y, so x squared and y squared. When we add them, we get 296. So it is a simultaneous equations problem. Now we've got squares in this equation, in this pair of equations, which means we can't really use elimination. We need to use substitution, which requires us to solve the first equation, the one that doesn't have squares in it, for either x or for y. Looking at it, it's going to be easier to solve it for x because that just requires us to move y to the other side. So from equation 1, we can say that x is y plus 4. Okay, so we have what x is, so we have something that we can substitute into equation 2. So sub into equation 2. So x, well, we know that x is y plus 4, we just found that. That squared plus y squared equals 296. Okay, so that's what we've got to solve. And that is one equation, but it only has one letter. It's looking quadratic. So we need to expand out that y plus 4 squared. So y plus 4 squared plus, if we expand that out, we'll get y plus 4 times y plus 4 plus y squared equals 296. Y times y is y squared plus 4 times y, another 4 times y, gives you 8y plus 4 times 4 is 16 plus y squared equals 296. So we've got 2y squared plus 8y plus 16 minus 296 is minus 280 equals 0. Now we move the 296 over to this side because we want to have everything on one side of the equation. This is a quadratic. Now that we can divide through by 2. So we'll do that. If we divide that through by 2, we get y squared plus 4y minus 140 equals 0. We can solve that by either using the quadratic formula or by factorising. I'll factorise it. So we're looking for two numbers that add to positive 4, but they multiply to negative 140. So let's do our systematic thing. We're looking for the pairs of numbers that multiply to negative 140, and then we'll choose the one that adds to 4. So the combinations are negative 1 and 140, or 1 and negative 140. We can divide 2 into 140, so that gives us another couple of pairs. 3 doesn't go in, but 4 does. It's 4 times 35. And 5 goes in. 140 divided by 5 is 28, so this will be negative 5 and 28, and 5 and negative 28. 6 doesn't go in, but 7 does. It's 7 times 20, or 7 times negative 20. 8 and 9 don't go in, but 10 does, so this is going to be minus 10 and 14, or 10 and negative 14. So which pair adds up to 4? It's going to be the negative 10 and 14. So this factorises into y minus 10 times y plus 4. So therefore, the solutions to this equation are y equals 10 or negative 14. So we're told they're positive whole numbers. Well, we are getting whole numbers, so that's a good sign. Positive whole numbers means that we can disregard negative 14. So y equals 10 is one of the numbers. Now from equation 1, we can substitute that into y plus 4 to get x equals 10 plus 4 is 14. So x equals 10 plus 4 equals 14. So we have our two numbers, we have x and we have y. So we should, from a word problem, write out our solution in a way that translates it back into the context of the original problem. So the original numbers were 10 and 14. So the numbers are 10 and 14. So let's check that to make sure that they do indeed fit the bill. Well, we have, they do differ by 4, because the bigger one minus the smaller one does indeed give us 4. 14 minus 10 is 4. Now their squares, what are their squares? 10 squared is 100, 14 squared is 196, 100 plus 196 is indeed 296. So yep, perfect. Okay, on to B. So we have two positive integers, add to 10. Their squares differ by 20. Find the integers. So we need to work out what our two equations are, which means we need to do the translation. So two positive integers, again we'll call those x and y. These add up to 10, so when we add them, we get 10. So that's the first equation. Their squares, which are, I'll actually write this the other way round, y squared and x squared. Order doesn't really matter there, but we're asserting, because this is about difference, this equation, we're asserting which of the two numbers would be bigger. Writing it this way is going to assert that y will be bigger than x. Their squares differ, so that's a minus because we're thinking about the difference, is 20, which is equation 2. Okay, so we need to solve this for either x or for y from equation 1. Because it's x plus y, it really makes no difference whether we solve for x or solve for y, but it would be, looking at equation 2, best to solve it for y, so we don't really have as much risk of getting tangled up over negative signs. So from 1, we'll solve it for y. So from 1, y equals 10 minus x. Solving equation 1 for y just amounts to moving the plus x to the other side. Now we'll substitute into equation 2. So substitute into equation 2, so that will give us 10 minus x, that squared, minus x squared equals 20. So we've got to expand out 10 minus x times 10 minus x squared equals 20. So 10 minus x times 10 minus x, 10 times 10 is 100 minus 10x minus 10x. Then we've got minus x times minus x is plus x squared. Then we get minus x squared equals 20. So we've got an x squared minus x squared. So those will cancel out. Now that's interesting, because this will no longer be a quadratic equation, which means it will only have one answer. We won't even have a negative answer that we need to disregard. This will genuinely just give us one solution. Okay, so that means we're going to move everything to all the x terms to one side and the numbers to the other side. So minus 10x is minus 20x equals, we're moving the 100 to the other side, which is going to be 20 minus 100 is minus 80. Divide that by negative 20, so we get x equals 4. From equation 1, we can say that y equals 10 minus 4, which is 6. So the integers, let's write that as a sentence, just translating the solution from the math problem back into the context of the word problem. The integers are 4 and 6. Okay, so let's check our answer. So our two numbers were 4 and 6, which 4 plus 6 is 10, so they do indeed add to 10. The squares differ by 20. Well, 6 squared is 36, and 4 squared is 16. 36 minus 16 is 20, so the squares do indeed differ by 20. Okay, thanks for watching. Over and out.